I think.
All right. Yeah, welcome everyone. So yeah, before we start, I should say if you have already been to the session in the last hour that was held for staff on the Zero Carbon Masterplan, this will be the same thing. So you might not want to sit through this as well. Otherwise, yeah, welcome to the Climate Network and our January Thursday session. We are, if you don't know who we are, we're a network of people at the University of Manchester, staff and students who try to make sure that we're not doing things in silos and that we're talking to each other and making things happen as best as possible. We have an email that goes out fortnightly with everything that's happening at the university and further afield as well. So you can sign up to that via our website, which we'll put in the chat. And then we also have these Thursday talks. So without further ado, I'll pass you on to Richard from the sustainability team and Harriet from Arcadis to talk about the Zero Carbon Masterplan. And we'll have time at the end for discussion as well when we'll stop the recording.
Great.
Richard.
If I kick off, good afternoon, everyone. My name's Harriet and I am a project manager from Arcadis. So I've been working alongside Richard and the team for the last 6-8 months or so, since the middle of last year, to develop a zero carbon master plan for the university. So just to give you an overview of the session today, we'll hand over to Richard in a moment for a welcome and some scene setting. And then I'll be talking through some of the principles of the different aspects which we're considering as part of the master plan. So these at this level are quite high level solutions, sort of indications of the things which could be implemented. And then we'll have time at the end for Q&A. And along the way, we're going to have a couple of interactive elements using Menti. So we'll come to that in due course, but for now, over to Richard.
Thanks, Harriet. Thanks very much. So yeah, thanks for having me along. Thanks for inviting me. I appreciate it. It's good to continue talking to you guys, and I appreciate what you're doing. I think probably most of you know who I am or have spoken to me on a few occasions now, but just in case there is anyone, I think there was 1 or 2 names I didn't recognise, so I'll just describe who I am. So I'm Richard Smith. I've been doing the job of Head of Environmental Sustainability at the University of Manchester for precisely 1 year and 2 days. It was my anniversary this week. Very privileged to be here. I'm still learning about the university's culture and its structure and its governance and everything really. It's including its environmental impact. So every day is a school day for me at the moment. So if I drop any clangers in the next half hour or so, then please bear with me. Prior to joining the university, I had a similar role at the BBC down the road in Salford. And going back a long way, I was a journalist. I was a BBC correspondent. I was a Home Affairs correspondent, which is a kind of fancy name for crime reporter to a certain extent. So superficially very different to what I'm doing now, but actually it gave me quite a good grounding for the approach that I have to take. So I lead a small but very dedicated, very brilliant team of people who are as committed as I am to ensuring that the university is a force for good environmentally. There are environmental aspects to pretty much everything that the university does, and our job, my team's job, is to understand what those impacts are and to take steps to counteract them and ultimately be, as I say, a force for good. It's very challenging, but nonetheless, that's the job we're here to do. We're in the process of drafting a new environmental sustainability strategy, which will encompass all the activity that the university does. And we hope that will be complete sometime this year. But the first challenge that we have really is the zero carbon one, which I'm sure you're familiar with, and that's what this session is about. Have we got the next bit, please, Menti, Harriet? So what we're going to do, I know we could all just talk amongst this, but we'll go with the Menti thing anyway because it's quite fun. So what I'm going to ask you to do, if you've not used this before, is on whatever device you're looking at, go to menti.com and put in that code 78413297. It's not complicated, you know, even I could do it, right? So and you'll be faced with that question: what does zero carbon mean to you? And all I'd like you to do is just type in a few words answering that question in whatever way you see fit, and then we'll have a look at them. I can hear some typing, so someone's doing something. Alternative energy sources. Yeah. Alternatives to fossil fuel, I presume. Any others? Anyone else going to chip in? Okay, looks not. So I'll carry on. So next slide, please, Harriet. Let's have a look. That's it. So we're talking about Zero Carbon Master Plan. So why do we even need a Zero Carbon Master Plan? I'm certainly not going to talk about climate change and all the issues that come with that, because you guys will be very well aware of it. I'll just give you the kind of context in terms of the target setting. So you may well know that in 2018, the mayor of Manchester, Andy Burnham, announced a target of the city, not GMCA, which is a slightly different thing, but the city of Manchester becoming zero carbon by 2038. And within the city's so-called carbon budget, more of which later on. Several other large organisations across the city also signed up to that target, and one of them was the University of Manchester, which did so in 2019. So that was 3 years ago. The target is in 16 years' time, although it has that carbon budget element attached to it as well. So by whatever frame we're using, we have to crack on, and that's with action, and that's what we're trying to do. Next one, please. So we're frequently asked what is included in the target. So this is the only technical slide I think that you'll see today. When we're doing carbon accounting, it falls into 3 buckets of carbon, 3 buckets or scopes of carbon: the scope 1, scope 2, and scope 3. Scope 1 is the carbon that is emitted as a direct result of us burning fossil fuels. So that's the kind of greeny colour that you see in the middle, the direct emissions. So that would be from the burning of gas that comes through the pipes into our boilers, and we burn that directly, and carbon is emitted as a result, and also through use of fleet vehicles or company vehicles, as it says there. So those are our direct emissions. Scope 2 is the pinky red swish that you can see on the left-hand side of the screen, indirect emissions from purchased energy. So that means that we use obviously a vast amount of electricity. The electricity requires fossil fuels ultimately, to a large extent, at least at the moment, for that energy to be produced. So although we're not emitting the emissions directly on site, on campus, they are being emitted as a result of our heat or our electricity demand. So those are our scope 2 emissions. So that's just about electricity. And scope 3, which was the swoosh on the right hand side, the blue, that's everything else, and that's a big bucket, and that's everything from stationery, catering, travel, investments, you name it. Everything else that's not the stuff that's covered under scope 1 and 2 goes into that scope 3 bucket of carbon. So the zero carbon target, which I'm talking about today, only covers our scope 1 and 2 emissions, not scope 3. So you may well ask, why is that? It's simply because scopes 1 and 2 are far more in control. We're far more in control of what happens with scopes 1 and 2 than with scope 3. So we're tackling them first. We can decide to a certain extent how much energy we use in our buildings. We can decide to a certain extent what that energy is. We're far more in control of it. It's far harder to control scope 3. Some of aspects of it are much more easy to control, like travel, although that's still difficult. But getting the word out to your supply chain, our thousands of suppliers, finding out what their carbon footprint is related to the product or service that they provide for us, and getting them to reduce it, or working with them to reduce it, is far harder. But I must stress, scope 3 is not something that we're not thinking about. It's just not in the scope, no pun intended, of the zero carbon target that we're talking about today. Next one, please, Harriet. So having defined that the estate, our buildings, and also our fleet vehicles are in scope, here's a few facts and figures about the estate itself, which I'm not going to run through. The key thing that you need to know really is the estate of the University of Manchester is basically massive in terms of its size compared to the majority of other universities in the UK. We're second only to the University of Cambridge in terms of size, and even then they're only larger than us just by a little fraction. We also have a wide range of different buildings. We have historical buildings. We have shiny new builds. We have average builds, if you like, the buildings that were built probably from the 60s, 70s onwards, not necessarily the most energy efficient. We have different types of buildings. We have buildings like full of admin people. We have buildings that are rural. We have buildings that are full of science labs, highly complex equipment, and each one of these presents its own challenges in its own different way. That said, I don't want to give us an excuse, because every industry on the planet will say that they are special and they are unique, and it's harder for them. So we all need to get cracking on it, regardless of the complexity of doing so. Next slide, please, Harriet. So we do have one thing that most businesses don't have, however, and that is a crack team of climate scientists at the Tyndall Centre. And not just them, but we have academic expertise across the board in everything from biodiversity to geothermal energy and everything else in between. And that's even leaving aside, of course, the general staff and the students that we can draw on as well. But in terms of the academic expertise that we have, that is a real advantage that we have over a conventional business. And I hope and expect that we'll be able to tap into that academic expertise wherever we can find it, and wherever the offer of help is there, which it always is in my experience so far. In relation to the zero carbon target, it was the Tyndall Centre who set that original target for the City of Manchester. They are the experts, so I'm very, very fortunate to have them on hand to sense check what I want to do or what we need to do. They play a critical role in supporting me and the university, and they're going to, they provide data and they keep us honest, and you can't ask for much more than that, really. Next one, please, Harriet. So what we're going to do for the rest of the session is, I suspect Harriet will talk for probably up to about 10 minutes or so, maybe less, about the hypothetical solutions that we have available to us in terms of decarbonising the estate. So keep in mind, this is about decarbonising the estate. It's not about all the other different things that we have in relation to Scope 3, although if you want to talk about them afterwards, we can do that. So nothing has been decided yet in terms of the Zero Carbon Masterplan, which, by the way, is a working title. The title may change in the future. I suspect it probably will, but that's what we're calling it for now. So Harriet will run through the hypothetical potential solutions. She'll mention lots of things. None of them will definitely happen. None of them will definitely not happen. These are just the tools that are available to us. And as the plans start to formulate and firm up a bit more, we'll get a better sense of where we need to go, and hopefully we'll be able to talk to you about it more further down the road. But that's it for me for now. Over to you, Harriet. Thank you.
Thanks, Richard. So moving on to the Zero Carbon Masterplan and what are the main elements that we have considered as part of this work. So the three pillars that we've got here in this jazzy diagram are the energy efficiency, heat and energy procurement. So starting on the left, energy efficiency is all about reducing the total energy that we need across the estate. So this could be both electricity and heat, and what measures we can do to bring that demand down so that where we do need heat and electricity that is zero carbon, we need less of it. So that's the first thing that we considered in the methodology. Secondly, we've got heat. So heat is one of the biggest challenges across the estate to decarbonise. Primarily, there are a lot of gas boilers. So we need to think about how can we heat this very large, in parts old and inefficient estate without emitting carbon. And thirdly, in terms of energy procurement, so where does the energy come from? And in an ideal world, the best situation would be that the university could generate renewable energy on its site, so have enough solar or enough wind to produce all its energy within its own land. But there are constraints. It's a large campus, but it's in the city centre. There are lots of restraints in terms of available land, in terms of, we'll come on to it later, but the listed buildings, in terms of the structural potential for example, putting solar panels on the roof. So although we'd like to generate all our own electricity, that's not possible. So for the energy that we do need to buy, we need to make sure that we know and understand how that's generated and that this is renewable source. So these three factors are kind of the pillars that feed into the overall master plan. And just to highlight here, we've got a little Siemens logo at the top. So Siemens were appointed as a sub-consultant to develop the technical backing to this. So whilst I'm speaking to it, I can't take all the credit. Siemens have built a model, and a lot of the stuff comes from their work, but they were not available. So you've got me. So we're just going to talk through some of these principles and what they might mean for the campus. So starting with energy efficiency, the first one, which I'm sure you'll be very familiar with, LED lighting. So lighting is a big potential source of or requirement of energy demand, and the university's already made some steps towards rolling out LED across the campus. And I think our records indicate that's about 35% of the campus is lit by LED. So there's still a way to go to completely roll out LEDs across the campus. And there are other technologies that we can look at incorporating as part of this rollout, which might include passive infrared sensors. So more smart lighting so that they can automatically turn off if the room or building is not occupied. And we can also fit other sensors so that we can control and make the use of lighting more smart depending on the needs and to optimize the efficiency even further. The next example we have on this list is called baseload optimization. So what the baseload is basically the energy used by a building when it's not occupied. So when everyone goes home at night, how much energy is that building still using? And this could be from essential systems that still need running, or it might be that simply people haven't turned off the lights, they haven't turned off their computers, various things are still running. So a key area that the university could reduce its overall consumption and be more efficient is to undertake this process known as baseload optimization to make sure that the energy that is being used while the building's unoccupied is stuff that really needs to be happening. So this might be things keeping science experiments going, essential emergency systems, fine, they can have their energy, but if it's just wasting energy on things that don't need to be turned on, then we can avoid that wastage. And this is a really quick win. It could be as simple as physically employing someone to walk around the buildings and switching things off at night, and or ultimately you can control it more through BMS systems, which we'll come on to later. But something that's I found really interesting from the baseload optimization studies which Siemens carried out is what's known as spillover savings. So whilst you could go around in the evening, turn off all the computers and all the lights, you'll save that overnight when there's no one there. But there's also the saving when the people come in the next morning and they don't necessarily need to turn that computer on at 9 AM. So as well as having that saving all overnight, you've also got potentially the whole next day and the next night, or however many hours in the day when that isn't needed. So there's really quick wins, which, although it's a small contribution to the bigger picture of the carbon of the estate, is something that's very doable, and you can really see the results very quickly. The next point is around BMS upgrades. So the BMS is a building management system, and it's effectively a computer-based control of how the systems in a building are controlled, and also helps with monitoring. So you can connect up all of your sort of electrical mechanical systems to your BMS, which can give you greater understanding of the building's energy demands, how it's used, and be able to control them often remotely to make sure that they are being used to an optimal capacity and efficiently. So a part of what the university could do is upgrade some of these systems. So we've got the most up-to-date and efficient BMS system, and as much of the infrastructure is connected into this to help build that picture of what's going on the campus and be able to control that in order to reduce that carbon footprint. And the last one on this list here is around building fabric upgrades. So this is about the walls, the windows, the roofs, particularly in the older buildings. These are very inefficient, even maybe the design of a building that has external doors which are constantly left open, letting all the heat out. In some cases, there could be quick wins in terms of maybe secondary glazing, but in some of these, it might be more of a deep retrofit, as we're calling it, which can require quite a lot of work in order to better insulate the buildings, so that we're not wasting energy, especially in terms of heat. So those are just some elements of the energy efficiency pillar. The next pillar we've got around heat and how we can decarbonize the heat sources. So at the moment, the campus has a lot of gas boilers, which to be zero carbon would need to be phased out. The sort of flavor of the month is the heat pump, which have been in the news a lot recently. And primarily the recommended heat pump type would be the air source heat pump for campus. There are other types where you would transfer your water from the ground or from water, but in terms of the requirements, in terms of having a suitable water source or having a suitable area for installing ground, that's less viable in the campus environment. So the way that the heat pump works is you transfer your heat from, for example, your air. It goes into your external unit. There's an electricity supply, which then there's a refrigerant which compresses to heat up your air even further. And then this is transferred to your inside unit and can heat the building. So potentially heat pumps are a great source of alternative heating in our buildings, but there are further upgrades potentially required in the buildings because they supply their heat at a lower temperature compared to say gas boilers, which work on a high temperature system. So it's not just a case of sticking in the heat pump, you also need to think about how that heat moves around the building through your radiators and so on. So the second one, which is quite an exciting one, but still there's a lot of uncertainty. The level of certainty that this would be viable is still fairly low, relatively speaking. But the principle is that the deeper you go into the earth, the hotter it gets. And whilst you can have ground source heat pumps, which are generally shallower, there's what's known as deep geothermal, where you would drill wells, potentially under Manchester, around 4 kilometers deep. You'd have 2 wells, a production well and an injection well. And it's a means of extracting heat from deep in the earth, which can then be used to heat your buildings. And the benefit of this would be you've got a more consistent supply. You don't have the fluctuations that would be associated with an air source heat pump, but eventually you will deplete your source if you're taking out heat quicker than it can be replenished. And it's obviously a big infrastructure. You've got to drill very deep. So whilst it's a really exciting thing that we're looking into, and we're engaging with the academics at the university, for which there's a really great research group who we've met with. This is something we are still looking into, whether it would be possible at the university. And the third point just to talk to is around energy procurement. So as I was saying earlier, ideally we would have our renewable energy on site, but in terms of wind, there's not really the space to put up some turbines that would have a meaningful generation capacity. And in terms of solar, whilst there are a few roofs that have identified which might have suitable capacity, there's a lot of issues around building ownership, structural integrity, and whether they're listed, which means in reality, the energy that we can produce is a drop in the ocean to what the university, the campus needs. So what we've got here is the example of a power purchase agreement, which is basically a contractual mechanism for committing to buy energy from a provider for a certain period with certain delivery mechanisms. So in this case, we can look at a power purchase agreement where all of your energy would come from, say, a wind farm. So you know that it is a renewable source, and that would be a contractual period of anywhere from 3, 5 up to 20 years. So that's another way of ensuring a renewable supply. So we've got another question here. We can drum up some interaction. So we're going to head back over to the Menti, and it's the same code. And there's one more question. I'll click over. So the second question is, why is a zero carbon campus important to you? So why is it important that the university does something about its carbon footprint? I'll give you a few moments to get thinking.
Don't be shy, folks. Get writing.
Here we go. It's a big impact, definitely. So as Richard was mentioning, it's potentially the second biggest university. You've got a very big estate. It makes me feel proud to work here. Yeah, definitely a sense of pride in doing the right thing and perhaps being a leader in environmental and carbon fields. We've got a couple more. We are responsible for the activity which we can affect, whether it's personal or organizational. Yeah, definitely. There's something, although it's very difficult to decarbonize the whole estate, it's not impossible. So if you put your mind to it, we can affect it and make a difference. And to tackle climate change, but also because the campus is a big part of the wider city of Manchester. And we've got, it would mean I'm not contributing negatively to the climate emergency by choosing to study in Manchester, definitely. And it's an essential part of a healthy and livable planet. Great, there's some really great things and thoughts there, thank you. So now I think my last slide is just onto the Q&A. So I'll stop sharing for a moment. And then I think we have 4 things in the chat. I haven't seen what they are. If they're questions, let me find the button. So yeah, we've got BMS building management system. If that's not what I said, apologies. That's what I said in my mind. And Siemens describing it